Good morning for a second time. Welcome to the Forum on Reimagining Supply Chains for National Resiliency. Supply chains are critical for our well-being. They touch all critical sectors, including aerospace, agriculture, defense, energy, healthcare and pharma, microelectronics and semiconductors, transportation and logistics, and many more. When they fail, we suffer, as we learned during the COVID-19 pandemic. We also learn that the challenges we faced then can be overcome if we reimagine supply chains with the goal of ensuring our national resiliency. This reimagining must take place with a view of resiliency for today, tomorrow, and well into the future. We have an exciting forum that's planned. With the help of our moderator, Deanne Bell, today's panelists will help explore conversations on the supply chain that will revitalize the U.S. job market and deliver a quality of life at the points of need on Earth and in space. Our panelists are from some of industry's leading companies, and we are grateful that they are here to lend their time, expertise, and perspective. Today we have Dario Gil, IBM, Steve Walker from Lockheed Martin, Taiyin Yang from Gilead Sciences, and Russell Allgor from Amazon. The full bios of our panelists are in your program and on the annual meeting webpage. I'll start the forum with a short introduction of our moderator, Deanne Bell, who you met during the plenary. And from there, Deanne will introduce each of our panelists, who will then have 10 minutes to present their topics individually. Afterwards, Deanne will open the floor for discussion and Q&A from our audience. I encourage you to engage, ask questions, and be part of the solutions being discussed. I'll start off by introducing Deanne. Deanne has moderated this panel for several years. I think we decided it was five earlier.
Years.
And many of you already know her. She's a mechanical engineer by training and her first job, television host and entrepreneur. Her television hosting credits include PBS, ESPN, Discovery Channel, National Geographic, DIY Network, and CNBC's Make Me a Millionaire Inventor. She is also the founder and CEO of Future Engineers, an education technology company that engages students in online contests and challenges. Recently, her company was selected by NASA to host the Mars 2020 Name the Rover contest. As I said, she's a mechanical engineer and previously worked at Raytheon as an optomechanical engineer. So now, over to you, Deanne.
Thank you. And I see that everyone's coming in, and I just want to say welcome to the 2024 National Academy of Engineering Annual Technical Forum. This year's forum, as Al mentioned, is all about reimagining supply chains for national resiliency. And, during the COVID pandemic, we all saw how disruptions to supply chain can shock the economy and affect the livelihoods of people all across the globe, across so many sectors. And while supply chain is a complex global issue, it's also an issue of national importance. And in recent years, as Lori spoke about earlier, we've seen greater attention, legislation, investments, and commitments being given to the national urgency of developing a more resilient supply chain and reshoring key industries back to the United States. And today, our forum is going to tackle just that. We're going to focus on this call to action for our nation's top engineers to come together and reimagine next-generation supply chains. And I'm honored to be joined on stage today by our four panelists, four of our nation's leading experts in their respective fields, who are going to speak about the unique challenges of supply chain resiliency in their sectors. And I'd also like to add that all of our panelists are NAE members this year, which is quite exciting. Next to me, we have Dr. Dario Gil, who's Senior Vice President and Director of Research at IBM. Next, we have Dr. Stephen Walker, who's Vice President and Chief Technology Officer at Lockheed Martin. Then we have Dr. Taiyin Yang, the former Executive Vice President of Pharmaceutical Development and Manufacturing at Gilead Sciences. And our fourth panelist is Dr. Russell Allgor, the Chief Scientist for Amazon.com. Now, the way the forum is going to work today is each of our panelists are going to give a little mini presentation to really educate you about supply chain in their fields. And then after we conclude all of those presentations, we will open it up for questions. And we have a healthy amount of time for questions. So at that point, we'll ask you to go to the microphones, and we'll be taking questions from all of our members. So without further ado, we'll go to our first presentation. I'd love to introduce you to Dario Gil, who I mentioned is IBM's Senior Vice President and Director of Research. Dr. Gil is responsible for IBM Research, one of the world's largest and most influential corporate research labs. He directs innovation strategies in hybrid cloud, AI, semiconductors, quantum computing, and exploratory science. He heads the technical community of IBM and is responsible for the company's intellectual property, strategy, and business. Dr. Gil is also the chair of the National Science Board, which oversees the National Science Foundation. An advocate of collaborative research models, he co-chairs the MIT IBM Watson AI Lab, which advances fundamental AI research to the benefit of industry and society. He also co-chairs the executive board of the International Science Reserve, a global network of open scientific communities that provide specialized resources to prepare for and help mitigate urgent, complex global challenges. Dr. Gil has served on a number of councils, the U.S. President's Councils of Advisors on Science and Technology. He's a member of the President's Research Council of the Canadian Institute for Advanced Research, the MIT School of Engineering's Dean's Advisory Council, and the Aspen Global Cybersecurity Group. He serves on a number of boards, SIA, CSIS, New York Academy of Sciences, New York Hall of Science, and RPI. And he's a member of the Academy, as I mentioned before, with a PhD in electrical engineering and computer science from MIT. Take it away, Dario.
All right, well, thank you. It's a pleasure to be with all of you. And I thought I would cast the brief remarks I want to make on the topic of computing, composed of semiconductors, AI, and quantum, in what has changed in dealing with the challenges of global supply chain, let's say a decade ago and the current moment. And the way I would like to frame it is that we see now technology as being elevated at the same level of geopolitical importance as things like trade or military alliances. And as a consequence of that, the complexity for all of us involved in dealing with that global supply chain have changed quite dramatically. And the first thing I would point out of how the nature has changed is who gets to shape the rules of the game of which we have to operate in providing this secure supply chain in these areas. And I'll cast you and I'll point you to a moment that I think crystallized it for me. And that was when Jake Sullivan, who is the National Security Advisor of the United States, gave a major technology speech in which he said, along these lines of technology as a currency of power, that there will be three sets of broad technologies that will dominate the conversation of the intersection of technology and national economic and national security. And that was computing as a category, and I will comment on both semiconductors, AI, and quantum, which he delineated as the three core elements of computing, biotechnology and biosciences and the implications that sector would have, and energy. And he says, of course, there will be a number of other ones, but these sort of broad categories are going to dominate a lot of the conversation. Now, within that, and following on the remarks of Director Locascio, I'll give a context of the consequence of that elevation of technology to that level of importance. And broadly speaking, let me analyze the problem just like Director Locascio did to give you some numbers and some of the dependencies and vulnerabilities that we have, and cast the actions that have been taken in our country in the categories of the promote and protect. What were the policy actions that are, have an implications for where we will manufacture and where we will do R&D, and what are the limitations of where we can conduct R&D and where we can source critical supply chains. So I'll start with semiconductors just to give you a flavor for this. The contrast to what I'm talking about is the contrast of multiple decades of globalization. And in globalization, the way we manage under that paradigm was you're optimizing around economic and cost advantages. There was a lot of focus also of just-in-time supply chains, etc. But in a course over many decades, it led to hyper-concentration. So for example, if you look at the semiconductor supply chain, what this shows is whether we're talking about the design phase of designing microprocessors or accelerators or memory, and the manufacturing of semiconductors broken down by front-end fabrication and back-end that includes assembly and test around that. And what it shows is what activities have greater than 65% concentration by just a few countries, right, in those areas. And what you see is that the United States leads the world in the design of semiconductors, and you see Korea in the design of memory. That on front end, you see a combination of Taiwan and Korea for advanced logic manufacturing. For less mature nodes, you see China, obviously, as a major player as well. And on the back end, again, heavily concentrated between Taiwan, China, and Korea. And then within that, there's a broad ecosystem of a supply chain in terms of electronic design automation, materials, equipment. That also, for example, in equipment, you see major players like the Netherlands, right, with ASML as a major provider, and in photoresist and many chemicals, the role that Japan plays, which is incredibly important. So one analysis is decades of globalization led to heavy hyperconcentration. Now, within manufacturing, Director Locascio already mentioned that we saw the relative erosion of manufacturing in the United States, peaking at 37% of global manufacturing of semiconductors in 1990, all the way down, this is the red lines at the bottom that you see, to around 10% by the time the CHIPS and Science Act were passed. And what you're seeing is also the growth, if you look at the top of China, Taiwan, and Korea specifically, as now having the highest amount of concentration. Now, I'll give you an observation. We did a careful analysis in the Semiconductor Industry Association of trying to assess the economic impact were there to be a disruption of chips from Taiwan. And I'll give you some numbers. This is just counting parts, okay? So this is not assuming any financial panic, all the other second-order effects. There's a chip. The chip cannot be sold or integrated into a car. The car cannot be sold. There's a chip. It goes into an iPhone. It cannot be sold. Just counting parts. The impact, were there to be a disruption of Taiwan supply chain, would be 11% of GDP within 8 months for the United States. If you look at other countries like Germany and Japan, and including China as well, that have a heavier dependence on manufacturing, the impact would be 16% of GDP within 8 months. Again, this is not, obviously there will be many second-order effects of consequence around that. So it is hard to overstate the implications were we to have a disruption of supply just from Taiwan alone. So what this led, as a consequence of this, was a reshaping of policy. And for the first time, well, particularly in the United States, I think we're seeing the reemergence of industrial policy as an element of the toolkit that the government wants to exercise, and that led to the passage of the CHIPS and Science Act. Now, the CHIPS is the only part that got appropriated with the $53 billion. And one of the implications that this has had, as we heard in the plenary talk, was a multiplication of investment, also leading with private sector, right? So you see about over $200 billion of committed projects on top of it. But I wanted to also highlight that this had also led to an international dimension of this. The European CHIPS Act aims to do something similar. In Japan, I'm giving the example of the Rapidus project that is building a state-of-the-art 2-nanometer fab in Hokkaido, Japan, also with many tens of billions of dollars of taxpayer investments around that. So you're also seeing this global coordination that is taking place from an industrial policy perspective. But I'll put it in perspective as well. Even if we succeeded in all of these elements, realistically, we are not going to reverse decades of this process of globalization in short order. At best, we could imagine anywhere between 20 and 30% of manufacturing capacity in advanced logic in the world of AI, in the world of semiconductors by 2030 or early 2030s. So this is going to be a tough problem that is going to require very sustained commitments for long periods of time between the United States and allies. And I emphasize that latter part because this is a problem that we cannot solve alone. Now, linked to all of this is on the promote side. On the protect side, we've also seen very assertive actions in terms of export controls of both semiconductor equipment, process equipment, design, and in the sort of adjacent field, because they're so intimately connected, the world of artificial intelligence as well. So if you're a leader now in industry dealing with this aspect of where can you sell, how do you manage all of this, how do you deal with the consequences of this control, how do we make the technical decisions as to what is controlled and not, and how do we get those metrics right, it's a massive problem. So this is not denying the fact that these technologies don't have huge national security implications. But again, this is an area where we have a lot of work cut out for all of us, including all of this community, to provide the right technical advice as to what and how should be protected. And also the challenge of understanding what are the economic consequences of implementing those export controls. Because for many of the leading technology companies, we derive most of our revenues outside of the United States by exporting technology around that. And that has a direct implication then on the profitability and the R&D that we can invest back into our country and be able to do these things. So I frame it as a set of challenges and opportunities around that. But what I would tell you as to wrap this up is that the time and how we spend our time as leaders in industry as a consequence of this elevation of technology to this geopolitical importance is so vastly different than it was 4 or 5 years ago. And it's not just linked to the pandemic. There's now these exercises of levers of power of both investment and protection on semiconductors, AI, and quantum that are truly reshaping the nature of global commerce, and that we have to exercise not only with the right level of technical expertise, but also in very close coordination with our allies to make sure that the United States continues to have access of markets with a competitive advantage. So stop there. Thank you.
Thank you so much. Wonderful stuff. I'm going to pass the clicker over. Thank you so much. All right. And then our next focus will be on the defense sector and aerospace sector. We have Stephen H. Walker, is Vice President and Chief Technology Officer at Lockheed Martin Corporation, where he's responsible for technology strategy, internal research and development investments, and laboratories. As primary liaison to the global science and technology community, he manages strategic partnerships with government, industry, and academia to support the development of cutting-edge technologies. Previously, Dr. Walker was director of DARPA and oversaw the development of breakthrough technologies and capabilities for national security. Throughout his 30-plus years in government, he served in several leadership positions as DARPA's deputy director and as deputy assistant secretary of the Air Force for Science, Technology, and Engineering. Dr. Walker is also a member of the Defense Science Board. Dr. Walker is a fellow of AIAA, a recipient of numerous AIAA awards. He's also awarded the Presidential Rank Award, the Air Force Meritorious Civilian Service Medal, and the DoD Exceptional Meritorious and Distinguished Civilian Service Medals. In 2020, he was inducted to the National Academy of Engineering, and he holds a PhD and bachelor's in aerospace engineering from the University of Notre Dame and a master's from the University of Dayton. Steve, I look forward to your remarks.
Thank you. Thanks, Deanne.
You're welcome.
And happy 60th anniversary to everyone. Apparently, I only have one suit and tie because it's the same one that's on the picture. But thank you for having me here today. Dario gave a great, and Lori Lacuccia gave a great intro to the microelectronics issue that we're facing. And I really appreciated Dario's intro because the commercial world and defense worlds are pretty different in what we have to deal with sometimes. And so I hope to give you a sort of a counter to what we have to deal with in aerospace and defense moving forward. So I want to give you a little primer on aerospace and defense because I'm not sure how many of you work in that area, but in terms of global A&D, it really supports three major technology areas. Obviously national security, but also transportation, space exploration. Our space company at Lockheed Martin does a lot for NASA and civil space. It's a global economic driver, especially and unfortunately when there is conflict all over the world. But budgets can fluctuate significantly depending on what a government wants to invest in and when. And so the sector can be up and down depending on what's happening in the world and where governments are investing. It's obviously controlled by a lot of government customers, and so those customers, and even within our own country, within the United States, Army, Navy, Air Force, Marine Corps, Space Guardian, Space Force. So each of those customers has their own priorities and where they put their money. The global market size this year is almost $1 trillion. So it's a big market. And I think that's why you see even a lot of commercial companies and small startups wanting to engage. Lockheed Martin's a pretty big part of it, at least in the US. We have about $70 billion in revenue a year, 122,000 employees, and 65,000 of which are engineers, scientists and engineers. So it's a huge engineering workforce. I know Al's we're trying to get more Lockheed Martin people into the NAE, trying to get more industry involved here, which I think would be a good thing. 20% of our employees are veterans, so a lot of expertise on the customer side in the company. But if you look at our supplier base, 13,000 plus suppliers over in 52 different countries. So it's a massive supply chain and very complex. As Dario said, technologies like AI are going to help a lot in trying to understand that supply base, especially as regulations change, et cetera. We have 4 main companies as part of Lockheed Martin, where we do our airplanes, Aero, MSC, Missiles and Fire Control, Rotary and Mission Systems, and then Space. And each of these business units is focused on, as you might expect, mostly platforms. I think, F-35, Black Hawk helicopters, JASSM missile systems, and a lot of our space assets. We do the Global Positioning System satellites, as just an example. So we are very much a platform company, and we've very much been a platform company. So lots of hardware, microelectronics is a key piece. But when Jim Taiclet, our CEO, came in about 5 years ago, and I came in about a week before he did, we laid out a strategy at Lockheed called 21st Century Security, and it's really about bringing more digital technology into the company, right, and combining that with our platform strength. And that is going to be incredibly important as we think about supply chain moving forward. So innovating with urgency is the first pillar, which is all about investing and working with others in the key technology domains that we're going to care about for the future. So Dario covered many of them, computing, and especially for our industry, edge computing. So being able to process at the edge is going to be incredibly important when you think about platforms operating at the edge. AI is incredibly important, and under this strategy, we stood up a corporate entity called the Lockheed Martin AI Center, which is focused on applying AI. We're not developing algorithms, but we're taking algorithms from universities and others and applying it to defense problems. And we think we're the best at that right now. And then areas like quantum and microelectronics are key areas. We have about 12 at this point. Digitizing and partnering is about, we understand that the defense industry is, in many of those areas, is not leading the way, right? It's the commercial sector. It's the commercial sector, the IBMs of the world, the other companies in that sector invest, as Dario said, a lot of money, and they have the freedom to do that overseas and in other places. And so we hope to be partnering with them to work in these digital areas and bring that into our platforms. The digitizing piece is really about how do we get better and faster within Lockheed Martin at building things. And so digital twins have been mentioned, but you can think about a whole digital twin of the supply chain for certain really important systems that we care about, and being able to model and simulate that supply chain to our advantage is going to be really important moving forward. Then transforming the industry. We are a highly regulated industry. Most of our customer base is government, and some of it is international governments. And every country has their own way of doing business. And so how do we transform the industry together with our customer is going to be really important for us. And we've been working with them on mission instead of platform, so understanding the missions they care about, where the gaps are, investing, and then who we partner with in that area to really bring that digital capability into the platform. And that's something we're trying to do with our customers as we move forward. Just one chart on the supply chain transformation that we're undergoing. As I mentioned, defense, aerospace and defense is highly regulated. We have a lot of issues on the left-hand side of that chart that we deal with. Export control was mentioned by Dario. That's a real issue for us. We can't just send any information we want to overseas, so we have to take that into consideration if we're working with an overseas provider. Critical materials is another one. I mean, rare earth metals. Rare earth is one aspect, and we really have found that magnet technology is really important in some of our platforms to reduce size, weight, and cost. But it depends on some rare earths that we can't necessarily depend on, as about 50% of the rare earths are in China and Russia. So what do we do there? And then getting more illumination into that complex supply chain I mentioned is going to be really, really important for us to ensure that the electronics, the microelectronics in the systems can be trusted and depended upon. On the right-hand side, as we look to transform, how do we build multiple sources? The defense industry contracted a lot back in the 90s on purpose. The government said we're going to have fewer contractors, the peace dividend and all that, and so we went to single source suppliers in a lot of areas. Semiconductors, solid rocket motors, some of the rare earth elements are just examples. We are now trying to diversify that supply base. One example is working with General Dynamics to develop a third rocket motor supplier for our needs. As Ukraine and other hotspots have happened in the world, our government customers asking us to increase our inventory of certain weapon systems so we can help our allies and partners. We can't do that unless we have multiple sources in some of these areas. So that's just an overview of some of the aspects that the aerospace and defense sector has to deal with in supply chain. We need to certainly get better at our partnerships with companies like IBM, and we are working together on some things. But that's going to be key for us as we try and bring these digital technologies into the supply chain that we have, the very complex supply chain that we have, and understand it better. And be able to create multiple sources, work with international governments to provide multiple sources, even overseas, in different places. As we just saw with the weather event in this country, you need multiple locations of supply chain to avoid issues like that. So with that, I'll turn it over to my colleague.
Great, thank you. So we've heard about supply chain and computing, defense and aerospace, and next we're going to look at supply chain resiliency in the healthcare industry. And our next panelist is Dr. Taiyin Yang. Taiyin Yang is the former Executive Vice President of Pharmaceutical Development and Manufacturing at Gilead Sciences, responsible for all the company's small molecules, biologics, and antibody drug conjugates of investigational compounds and marketed products. Under her leadership, Gilead developed the world's first HIV single-tablet regimen and advanced more than 25 compounds from early-stage development to market. Taiyin joined Gilead in 1993, became the Senior Vice President of PDM in 2005, and was appointed to the most recent role in 2015, which she held until July 2022. Previously, Taiyin worked at Syntex Corporation from 1980 to 1993, having contributed to the development and commercialization of more than 10 medicines. Taiyin Yang served as the executive sponsor for the Gilead Asian Interest Network and Employee Resource Group to promote, support, and encourage inclusion and diversity. She served as a member of the Expert Scientific Advisory Committee of Medicines for Malaria Venture, and she's the member of multiple scientific advisory boards, Ciana Therapeutics. She's also on the board of directors of Kodiak Sciences, Inc., Kronos Bio, Inc., and Brie Biosciences. She received her bachelor's in chemistry from National Taiwan University and her PhD in organic chemistry from the University of Southern California. And she's a fellow of the American Institute of Medical and Biological Engineering, and was elected a member of the NAE in 2022. Thanks, Taiyin. Go ahead and take it away.
Thank you very much, dear. Yeah, oops. Yeah, maybe I come back. First of all, just, good morning. It's such a privilege to be here. I've had a long history working in the pharmaceutical industry on developing, manufacturing, and supplying medicines. And so I'm very pleased today to tell you the stories and help plant seeds for the future. I'd like to steer you to view supply chains through a healthcare lens. Healthcare is a highly regulated industry, no less than aerospace, with the mandate to make available safe and efficacious medical products in a sustainable manner. So I will elaborate on drugs as an example. Health authorities regulate drug development in all aspects, and after product approval, their regulations govern commercial promotions, safety reporting, quality reporting, surveillance, inspections, and even down to the details of qualifying shipping lanes in all climatic zones. So the governance is very comprehensive. To support emerging technologies, health authorities have also created programs to increase dialogue, education, and input. Examples like predictive modeling, next-gen sequencing, robotic arms for aseptic filling, and ultra-long-acting oral drugs. These are all fascinating for the future. For present, for drug production, the long lead time is the norm, and obtaining regulatory approval is also a long and involved process. As such, drug supply chains often embed a just-in-case attribute because drug shortages have very significant impact on the consequence. I will highlight some of the relevant features. Having a safety stock policy across the entire supply chain, rare earths included, right, is key to safeguard against patient treatment interruptions. It's imperative to have reserve production capacities that is ready, not dormant, in a state of compliance. Considering the manufacturing network will be relevant to assess the geographic diversity, redundancy, point of use, onshoring, and U.S. Biosecure Act that is coming. I should also note individualized medicines requiring on-demand manufacturing, such as autologous cell therapy, calls for a different supply chain paradigm to address the real-time interface with treatment center, transporting live cells and producing one dose as one batch for a single patient. So in healthcare, I can't stress enough the criticality of quality and compliance, which underpinned availability of medical products. The regulatory approvals around the world, the requirements vary significantly by country, causing proliferation of SKUs. So investment in strategies of the 3 Rs and tools to break down the complexity will help assure the resiliency much. The world has seen 3 pandemics in the past 4 decades. There was the HIV pandemic outbreak in the 1980s. HIV persists today. At the end of 2023, 40 million people were living with HIV, and this number continues to rise. Past flu pandemics have activated national stockpiles of Tamiflu in many countries, you can see. So the pharma supply chain was put into high gear. Responding to the COVID pandemic, healthcare raced to deliver medical innovations and patient care. In the spotlight was also the recognition resilient healthcare supply chain mattered more than ever before. Pharma and biotech has invested in operations that are foundational to supply chain. Quality and compliance go without saying. Data integrity, after all, data is the currency. Another is the cybersecurity measures. Following the NIST cybersecurity framework, that has been a fruitful investment. Aseptic technology has advanced to have wraps and isolators. Sustainability, good for the environment, also makes good business sense from efficient use of resources. Many examples I can cite. Now I want to add an acronym to your vocabulary, CPV, Continued Process Verification. CPV is resource and computing intensive, mining from heterogeneous data sets, identifying trends, and adjusting processes to stay in a state of control. Finally, pharma serving the underserved, while not consistently seen, is worthy of recognition when done well. Gilead Sciences, along with FDA, the US Executive Office, WHO, and generic manufacturers have served HIV patients in developing countries well during a critical time of the pandemic. An open supply chain approach without IP constraints played a consequential role. Looking ahead, several transforming forces are at play. The emergence of new modalities of medicines and the technologies has been fast and furious. Consider cell therapy, gene therapy, mRNA viral vaccine, long-acting drug delivery, conjugated drugs, and the like. They will dictate customized supply chain strategies. Equitable patient access is no longer an aspiration. It's a force taking hold in clinical trials. Finally, geopolitical influences and natural disasters bring more acute impact. Here I plant some seeds about opportunities for discussion. digital transformation of supply chain has enabled the data analytics to reimagine the healthcare supply chains would mean we need to elevate the analytics further throughout the entire ecosystem of the supply chain with the transforming forces you can identify in mind. Next, nearly 2/3 of drug shortages stem from product quality and manufacturing issues, and about 2/3 of drugs experienced shortages were injectable products. As such, I see early opportunities of developing AI tools in manufacturing. For instance, product defects detection, assessing sterility breaches in manufacturing facilities, and operator training for aseptic technologies. These are likely will be image-based tools and can likely generate, I think, transferable algorithms that would be applicable for different products, facilities, and people. So I hold high hopes in its potential. So I'll stop here. Thank you.
Great. And our fourth panelist is Russell. There's a reason he's the end of the chain here, because he's going to be talking about the kind of the end of the supply chain with transportation and logistics and deliveries to consumers and customers. Russell Allgor is the chief scientist for Amazon.com, where he leads a team of mathematical modeling experts. Allgor has demonstrated outstanding accomplishments in practice, management, and research of operations research and management science, ORMS, at Amazon. He is one of the most influential scientists in the field of logistics and fulfillment systems for e-commerce. He and his team focus on using data analysis, modeling, simulation, and optimization methods to improve the efficiency of Amazon's operations. He's focused on problems including network design and facility location, inventory planning, order assignment, equipment and process design, vehicle routing, and process control within and across facilities. Ideas and algorithms developed by Allgor and his team have returned billions of dollars to Amazon's bottom line. Prior to joining Amazon.com, Allgor worked in applied R&D for Bayer AG in Germany. He holds a PhD in chemical engineering from MIT and a bachelor's from Princeton University, and he's a member of the National Academy of Engineering and an Informs Fellow. Russell, take it away.
Thank you. Thank you for the kind introduction. I'm going to switch a little bit and talk more about not how we get things to manufacturing, but how manufactured goods get to people. That's been most of my experience within Amazon. So I'll start a little bit with just trying to give a brief overview from a very Amazon-centric view of how things get to customers, but looking at what I would call the outbound supply chain network within Amazon, which commonly the company refers to as the process from click, when a customer clicks on a computer or mobile device, to deliver when the products finally get to a customer, or acquisition for the customer. So typically this process starts of a customer order with a computer or mobile device, customer selects an item or items that they'd like, and that's when sort of Amazon's processes start. The first estimate is to provide a customer with a delivery estimate right away of when they might get the products. The second step is to actually try to make that now come true. So the first step is usually choosing between the hundreds of fulfillment centers that Amazon has, which are the site's inventory locations from which we can ship products. And those fulfillment centers and the choices customers have, we have hundreds of fulfillment centers, but customers can choose from tens of millions of items. And so they're all under roof somewhere across the network, and that's just in the US. Typically, the product starts with looking for what fulfillment center to assign the order to, or the location or locations, and then the picking process starts. So the items are picked off a shelf or off a pod, as shown in this picture here, gathered together, and the items may be gathered into one box, and then that shipping process starts, and the package is either sorted into a container, which might be a cart or a pallet, or directly onto a trailer on the outbound dock of the facility, and then the package starts its journey typically in a tractor trailer. If the package is traveling a short distance, it might actually traverse all the way over to a delivery station and be routed directly there, where it can get in a delivery van and go to a customer. But if it has to travel a longer distance, we're probably going to bring it to a sortation center somewhere middle mile, called the middle mile network within our company. And that sortation center will sort the packages and consolidate packages headed to the same destination on a trailer or a cargo plane, where we'll transfer it across the country. So in the middle mile, there's a cargo network, air cargo, as well as transportation. And we'll use transportation carriers and trailers owned by Amazon, as well as owned by many third parties. That transportation process, if it's traveling a long distance, usually ends at another sortation center, where the packages will be deconsolidated, consolidated again to a delivery station. At one of the delivery stations, packages are typically sorted again. Lots of sortation, lots of handling here going on to get the packages to small containers, which are then loaded onto delivery vans, delivery vehicles, most of them vans, but delivery vehicle, and where they're routed and then delivered to a customer doorstep or other delivery pickup locations. So this network we have is a network of processing facilities like sortation centers, fulfillment centers, delivery stations, and transportation processes that interconnect those. And the network has several elements that make it resilient and to disruptions that we might face. The first is alternative supply points. So we have hundreds of fulfillment centers, and most of the items we sell are stocked in more than one location. Some in all 100 or in the hundreds, but many in a subset of those. The many stocking locations give us the opportunity that if a single failure, there's no single point of failure, if one of the sites has a power outage, if one of the sites has weather-related problems and has to shut down, there's many other ways they usually won't see customers, and customers to the company won't see a disruption. That even goes for many stocking points inside the facilities. You saw those inventory pods. Amazon typically stocks things in random stow. So rather than directed stow like you might see in a supermarket where all the chicken soup is together, we'll have individual items stocked in many places. This serves two purposes. One is you get better storage density out of it, so better use of overall resources. The other one is that if there's a disruption to an individual station, it makes it easier to line balance. So you can balance the lines by pulling from different places. And if there's a single point of failure inside the facility, a particular machine is down, usually doesn't disrupt the facility itself. So those stocking locations carry in both ways. Next, we have flexible capacity and supply. So overall, the company scales the infrastructure for the peak shopping season. So the time between Thanksgiving and through December typically drives the highest volume. So all the infrastructure is scaled for this peak time. So while we haven't built redundancy into the overall network structure, we have more than enough capacity throughout most of the year to recover from disruptions. And you can notice things like Prime Day or something like that, where the company also has able to scale the workforce to scale quickly and absorb small-term disruptions. So that flexible infrastructure, the infrastructure we have is flexible and allows us to drive those changes and deal with small disruptions. The network is also connected. While we've designed the network for efficiency and speed, cost efficiency and speed, by regionalizing the network, desiring to ship from local inventory positions to the customer, we also have an extensive middle mile network for ground and air. And we also have a flexible last mile delivery network, which considers Amazon direct vehicles where we can send things to customers managed out of our own delivery stations. But we also work closely with delivery partners like UPS and the US Postal Service who do deliveries. So a disruption to any individual facility, whether it's one of ours or a third party, doesn't usually disrupt the end customer, and we can adapt quickly from that. Another key is in managing this many structured network, highly connected network with thousands, hundreds of thousands of delivery vehicles, hundreds of sites and facilities, requires adaptable systems. So we have lots of automated decision systems that work throughout the planning, the design phase, the planning phase, and the execution phase. And these automated decision systems help us know where to place facilities. They also help us understand how to partition up areas of the network for localizing delivery and things like that. These automated decision systems employ optimization techniques, machine learning, and artificial intelligence to monitor what's going on in the systems, as well as change decisions to adapt to changing conditions. For instance, if there's weather and road conditions are bad, we can reroute the trucks across the network. Optimization is also successfully deployed both planning and execution, so also in acquiring supply. Our middle mile network uses transportation carriers. Most of them, we have relay load boards, which are automated, use AI techniques, prediction, machine learning, to drive a digital marketplace, essentially, of supply and demand, to connect with small providers for loads we pull or loads other companies have. And so all those things lead to a more resilient network that's adaptable to changes that come at it. So a lot of it's adapting using the technology to quickly change what we're looking at and quickly change the decisions we make.
Great. Thank you so much.
Thank you.
At this point, we're going to transition to questions. So go ahead and start lining up on the microphones. And I'm going to tee us up with our first question. And Russell, I think I'm going to keep you in the hot seat. You're talking about adaptability for all these changes. When I think of disruptions of supply chain, right, I think of some of these biggies. I think of geopolitical events. I think of cybersecurity threats. And think of large kind of climate events and weather. Of course, currently we're seeing the impacts of Hurricane Helene, and my sympathies go out to anyone impacted by that. But can you speak specifically to weather and climate, and what strategies or tactics there are for being resilient in the face of those unexpected weather events?
Yes. So I think one of the last slide that I didn't get to with time, but you can see that Amazon does have a notion of, we deal a lot with, or there are many weather events, disruptions around the world, and we pre-position supplies that will often be needed for those kinds of events, and we call them disaster relief hubs, but we have them for wildfires, for tropical storms and hurricanes and things like that. And so these disaster relief hubs have inventory pre-positioned in locations that are hopefully outside the path of whatever event would be there. Wildfires in California, so it's presented, or on the West Coast, primarily in the US, and tropical storms and things that hit the southeast of the United States. So I think over the past, since we've started with these disaster relief hubs, Amazon's delivered over 24 million items in over 160 adverse events, disasters around the world. So, and they're usually, these hubs are positioned near an air hub, so we can fly it out, whether it's to support local or more regional or international, so islands and things like that.
A lot of hubs. You talk about all these different hubs and the redundancy of it. Your whole life is hubs.
A lot of connections between everything. Trying to make sure stuff gets where it's going, and we know where it is. Use AI for that as well. So
great. Okay, we're going to go to our first question out in the audience. We will start over here.
Paul,
okay. Paul, you get to go first.
So Paul Westroff, Arizona State University. Thanks a lot for talking about these supply chains. There was a little bit of mention of critical materials in terms of the beginning of the supply chain, and then it was really about making things and delivering things. So I'm really interested in thinking about the rest of the life cycle of these materials in terms of end of life. For example, Apple has a program to take all these iPhones that are in the bottom drawer and recycle gold, and actually they want to meet certain types of certified recycled gold. So in these future supply chains, how important is you think recycling, this end-of-life or circular economy of these critical materials or even of plastics and other products, you think? Thanks.
I know Dario and Steve, you both talked about materials, but why don't you start, Steve?
I think we would put that in the category of, looking at, in terms of rare earth elements, a processing view of how to take maybe scrap material that isn't used and refurbish it into some materials we care about. People have looked at tallings as a way to do that and reprocess that extra scrap material and use it for rare earth element applications. And so we're working with a small company or two to look at that. If we can make that a reality, I think that's absolutely something we want to go after.
All right, next question.
Hey, thank you very much. This one is for Russ, and yeah, you knew I was going to do it. And Steve, perhaps Taiyin as well too. So you saw results over in Lebanon with pagers and radios and stuff like that. Steve, you're very aware of that. No. And so you have things that are inserted into the supply chain that are not supposed to be there. They're nefarious. In things like biosciences or other places, you can use feedback to understand when you have bad things in your supply chain because of their effect downstream and come back and eliminate those sources and figure out how to get them out. So the question is there anything that we can learn from the commercial sector to get things out of the supply chain before we actually use them? So before first use. And you can get them out of the supply chain or find a different route to still get the capability that you need, perhaps island things off, maybe even leave them in the supply chain so you can figure out where they're coming from and keep mining that. I'm wondering if there's sort of a crossover between what happens in the commercial world as well as in the national security world that could be learned here in this environment, in this open setting.
Maybe I can start on the drug side, as you mentioned, because pedigree is important. So from raw material all the way to the finished goods components. So that is something you have to maintain such that there's traceability. So there's a lot of governance, and therefore it also makes business sense to do that. Therefore, if there's oftentimes it's due to, say, expiry or stability issues that you uncovered later that you didn't know before. It's not necessarily bad. If they turn bad, they're not necessarily even bad. It's just the expiry has had a different definition for that material. It doesn't matter it's in an intermediate or in the finished goods. So I think it is resource intensive. I do think that's where more tools can help, is the pedigree to make it a lot more ready for access, because it's, drug companies do this, but in the meantime, I know how cumbersome and how labor intensive can be supply chain tools. Well, there's many commercial analytics that allow you to pull it together, but then it's all international as well, right? So I do feel it is a room, there's lots of room for improvements, but the key is in the pedigree. What went into which lot, to which pharmacy.
Right, and I think, with resiliency, we've talked about diversification, and I think at the core, it's just how do we ensure the quality of supply chain. And I know earlier there was talk of metrology and different tools. Do you guys have anything else to add in terms of this question?
Go ahead.
Maybe I don't know what was geared towards me, but I know one of the challenges that we face with inventory is making sure we may have the same items from different sellers. So you talk about nefarious agents. So much of which Amazon ships to customers are owned by small businesses. The small businesses own their inventory and entrust the company to maintain it and get the things they've given us to get to customers. So there has to be very tight tracking. I think that's what she was talking about as well, of the inventory. So provenance, so knowing it's the same item and where it goes throughout the system. So everything's tracked at sort of the individual item level, but without necessarily tag on it, but using vision technology and other things, we know where everything is at all times, and if something is out of place, you get pictures, AI, vision, you can know when, okay, something's missing here, we better find out where it went. Sometimes things get misplaced, but in general, the key is to make sure you know where every item is at all times and where it came from. Now that doesn't really, if something came in that wasn't right, doesn't help us, but at least everything is tracked from when we first get our hands on it. So if you can go all the way upstream, you could track things, with the same sorts of systems all the way through the chain. But that becomes, yeah.
I think to be careful
in the pharma industry.
be clear. So you'd know it's a bad thing after you use it the first time, and you can go back upstream to figure out where it's coming from. What happens if you really critically need to use it that first time and it has to be good, but it's not?
Yeah. Yes, that's an important problem. I think what the key is to what Taiyin said about pedigree. We don't use the word pedigree, we use trusted in DoD world. And making sure you have a trusted supplier for your critical components is absolutely necessary. We have a good sense for our supply chain, I would say 2 or 3 levels down. Beyond that is what we're trying to get better at in terms of understanding, using techniques like AI mostly to illuminate that lower level supply chain. But we need, because I mentioned most of our customers are government, we need to work with our government customer to understand whether they can work with us on that, right? Because you're going to need government participation, government customer participation in that. You're going to need their support if you do find something at a lower level, that they're not going to stop your program. They're going to work with you to figure out how to fix it. And so that's some of the regulation improvements we're working with our government customers on to allow that illumination all the way down to the lowest level, which I think is really important based on what we've seen. So.
Great question. Now let's go over here.
Hi, Christian Bellotti, new member. Thank you very much for the great session. I got a lot of insights, particularly Russell. I never really thought of trucks as the same as little data packets in the network. It's really fascinating to see the correlation there. But my question's a much bigger one in that we're talking about resiliency, and with the growth of AI, its capabilities 10x every 2 years, huge demand for infrastructure. And so I see us moving from a demand-driven economy to a supply-driven economy, and a lot more scarcity in the supply chain because everyone's going to be competing for the same capital. Already there's discussion in most of the newspapers about and the media on power demands of AI data centers. So there's going to be huge pressures on the supply chain that I don't think people are really thinking about. So I'd love to hear your perspectives on what you see coming, how your companies are preparing for this supply-limited economy in the future. Thanks.
Dario, how about that?
Yeah. So that has been a main preoccupation for everybody that's been involved in computing, certainly in the last couple of years, and a lot more to come. I would say on the first phase, in the AI world was about literally counting where every GPU was, right? And whether one can get access to sufficient blocks to be able to train foundation models and large language models. So that was a first phase, I would say over the last couple of years. I think the situation has improved, but now we deal with an issue of scale, right? The level of ambition and the scale of projects that people want to undertake. Now it's not uncommon to read on the headlines that people want to put a gigawatt, data center or things like that, which, by the way, just to give you a sense of the scale of that, by the time you add all the equipment, all the elements on that, That could be a $30, $40, $50 billion project, right, if you want to do something at that scale. So once you achieve that scale, now there's all sorts of other forces that are coming into play that have to do with, back to the theme of economic development, investment funds. So you're seeing, for example, non-traditional technology players like, let's think of a BlackRock or so on, now creating structured financial instruments like tapping into even things like pension funds and things like that to be able to invest on large capital projects that are at the intersection of power delivery, in terms of, gas centers. You've seen even headlines, right, of trying to revive nuclear power stations, right, to support data centers. So you're seeing this combination of large amounts of capital and many players, including economic development, not only in the United States, but around the world, to create this sort of next generation of AI-powered data center. Now, so that's like just description of reality. What do we have to do moving forward? Look, I think that, no matter how you look at these projections, it's an unsustainable path. We can't keep going, right, at a rate. I mean, at some point you can do a calculation and you can look at the land hour limit of compute, right? And if you keep extrapolating around, we'll run out of like all the power in the world, right? So there has to be a rethinking of architectures. There has to be an incorporation of efficiency. And, just like we have in microprocessors or power performance, this element of the metric has to be central to everything that we do. Has it been central? No, because it's been very much about the demonstration of capability. But a demonstration of capability scaled blindly is a very poor engineering practice, right? So we got to get now to a mode where this efficiency of the architecture, what is the right way to do things, with what techniques, moderates what looks right now like an exponential on the power side that ultimately will be unsustainable.
Yeah, just to add to what Dario said, that because of our defense application, I mentioned edge computing, edge processing. We're very focused on doing AI at the edge in a very small, compact space, and working with companies like IBM and other companies to develop those technologies. IBM Red Hat is one example I'm thinking of. And that type of tech development is leading to new thinking in terms of even the data centers, I believe, in terms of neuromorphic computing and other things. And so that's an example where a defense application is really going to, I believe, spur some innovation in computing for lower power, lower swap.
Great. Okay, we're going to go to our next question over here.
Yeah. My name is Dan Baker. I'm the director of the Laboratory for Atmospheric and Space Physics in Boulder. I study space weather and the effects of the space environment on systems. I guess I'll direct this question to Dr. Allgor, since he's the inventor of algorithms. But I guess I wonder, maybe for all the panelists, if you think about hazards and disasters that are much larger in scale, maybe continental in scale, that might affect satellites, communication, power, sort of all the key things that depend on one another, and how that would disrupt your commerce.
Great.
And
I think the question here is really kind of on communications as a disruption of supply chain.
communication and power supply and all the things related.
Okay,
right?
great. Does anyone want to take that on first? Russell, you're in the hot seat again.
I can't say that I have considered these problems myself, so
Okay.
it's, I think power is needed. If you're relying on computers, it's required, so.
Yeah, I think maybe I would take a stab. Really, it's about business continuity. That is practice, right? Power outage will happen, doesn't matter for what reason and at what frequency. So business continuity, I'm sure most industry, most company practice that. So that means you identify how many days, how many hours can you do without, and what is your solution? What is your alternative way to operate? So I think this is just a situation that is going to be painful, but it's something you have to be diligent, right? You have this business continuity plan down to a table exercise. Therefore, you can make sure your patient, in our case, patient gets their medicines, and business gets revenue, right? So in a way, I think you can generalize this being the thing to do. Doesn't matter how big the damage or the disaster is. You just have to know, with this particular segment, can I live 2 weeks without energy? What is alternative? Can I shut down? How do I shut down the facility without having mold growth, right? So this is all the ideas about just business continuity.
In the most severe cases, it could be much longer than 2 weeks.
Correct. You have to say, do you have different locations for operating the headquarters or the manufacturing or anything else? So I do feel there needs to be, it shouldn't be, imagination is the limit. It just have to be also with some practicality, right? Otherwise, you won't be treating your business continuity plan with as rigor.
Great. Okay, we're going to go over here. Next question.
Yeah, hi, Dick Miles from Texas A&M. And just in response to that question, I hope it makes Texas connect to the national grid. So I have a question, mostly for Steve, I guess. So some years ago, MIT came up with this just-in-time concept, and the whole idea was to only have your inventory arrive just when you needed it. And I think that didn't work out so well, and I wonder, what is the new approach? How do you deal with the balance between inventory and delivery so that you can have something which is ready and you're not so dependent on the supply line, but you don't have excess inventory?
Great question. So kind of balancing efficiency versus kind of redundancy and diversification.
Yeah, and I think it depends. It's different for Amazon because your inventory is probably less expensive, but you have a lot of inventory, and I guess you can't afford that in the aerospace industry.
Okay, I think we'll start with Steve. Yeah.
I can start. And it's very similar to what Russell talked about. And in terms of how DoD thinks about this now, one of the key things we're thinking about is something called contested logistics, right? So doing everything Russell can do in a contested environment where there is no comms, maybe where there is a lot going on, and you can't necessarily transport what you want in trucks or on the sea lanes. So we are would like to move towards a just-in-case, which I think you mentioned, a just-in-case scenario where things are pre-positioned where they need to be. We might even be able to do manufacturing at the point we need to do the products to show up. And so reducing the lines of transport, I guess I would say, when you need to in a contested environment is something the DoD is thinking a lot about. And certainly the Amazons of the world need to be brought into that conversation, I would say. But there are other things you can do, maybe more different ways to transport material as well. So I'll just start with that.
Yeah, well said.
I mean, on the supply side, just in time or just in case, there's most of the things, there's positions, so where you want to have the inventory and everything is sort of planned, but that's all plans are based on some estimates of the demands you're going to see. And so the better predictions you can get of what you're preparing for, then you can provide service levels with those distributions and things like that. But that's typically the way things are managed, but it's, for much of the inventory we have, we don't choose the levels, we just choose where it goes because it's managed by small businesses and we have to try to position it where it's going to be needed. So there's a lot of looking at demand patterns and things like that and trying to estimate where it's going to be most likely to be needed so that supply lines are short and not long, as you mentioned.
Talk about forecasts. Really, forecast is usually not correct. So you want to...
It's always wrong. Sometimes it's useful.
So I think sensitivity analysis is a key to designing your supply chain, right? When I talk about safety stock policy, it's about policy. You have to think ahead, right, about where your end users are and where your values are. So I do think so you don't want to be panicked on that spot. So policy can mean a lot of things for different companies, different goods, and different regions. So I do think as leaders would be, say, looking, what is your policy and why? And what are we leaving behind? And we all agree on that. Right? There's certain laws you just have to say, we'll manage it on the spot. Anyway, I'm rumbling, but...
Well, the only other thing I'll add is because people, when they think about contested logistics, at least I do, I think about something over there, right, happening. And I'm looking at David Van Wee because we were on a DSP study recently. And we actually need to be thinking about contested logistics here as well.
Great question. We'll go over here to our next question.
Yes, I'm Ron Latanison. I'm the editor-in-chief of The Bridge. But even more importantly, I am the Neil Armstrong Distinguished Visiting Professor in the College of Engineering at Purdue. And I really like being able to say my name and Neil Armstrong in the same sentence. It's just such an honor, and I'm really quite serious. It's the honor of my career to be associated with Neil Armstrong and my new colleagues in the College of Engineering. But I have a question on chips, and probably most directed towards Dario. My understanding is that the Dutch chip maker, ASML, not chip maker, but lithographer, is something of a gatekeeper, or maybe even a bottleneck in terms of the global production or movement towards the production of nanoscale chips. And I wonder a couple of things. How does that impact IBM? Is there an alternative to lithography in terms of even smaller nanoscale features? And thirdly, what would happen to the global industry if the Dutch decided to pull the plug on that operation? And there's a lot of questions, but I'm very curious and very interested.
Yeah, so ASML, I mean, I'm sure lots of people here know what ASML is probably the single most important company in the world, right? In terms if you trace back sort of like the implications were there to be a disruption there.
And they made a huge investment in putting this fab facility together.
Yeah, for sure. So ASML is a maker of lithography equipment, and at the most advanced sort of like equipment nodes for very high NA, high numerical aperture immersion lithography, and particularly extreme ultraviolet lithography, they are the only makers of that equipment in the world. Just to give you a sense of the scale of those machines, a single machine with a track, right, that supplies the chemicals to do the photoresist deposition, all those things, it's about €500 million, right, a single machine. Yeah. And it is, without a doubt, the gatekeeper, right? I mean, on that, the access to those machines is what enables advanced node production, right, all over the world. So basically, there's only one company that makes them, right, at the very high end. So as a consequence of that, it has a massive implications. And back on the promote and protect framework, actually, the United States, and in coordination now with the Netherlands as well, has imposed export controls to that technology. So EUV machines cannot be exported to China, as an example, right, around that. So then you can ask the question that you asked, what will the implications of that be to China, right, and their ability to manufacture advanced nodes? And basically what they have to do is they have to use older lithography equipment and do multiple layers of patterning, right, many layers of the same machine pattern over time, which for hero level of experiments and for small number of parts you can do, but it's very hard to manufacture at scale using that approach for advanced nodes. So yeah, I mean, it is an incredible level of dependency. And if you ask, well, is it easy to replace it or substitute it around that? It is not. It is probably the longest lead time if you plot all of the elements of a supply chain of making a chip. Yeah. And if you look at how easy is it to replace each of the elements of that long process, of which there's thousands, replacing a high numerical aperture extreme ultraviolet lithography machine. It's at the other end. It's like at the tail of the spectrum. It's probably, if you start from scratch, it's a multi-decade effort.
It would seem to me, and just a final comment, it would seem to me that this ASML has the potential not only to slow the supply chain, but it could be a break in the supply chain. If they decided to stop operations for whatever reason, that would be monumental, wouldn't it?
They cannot stop operations.
That's what I thought. Okay, I rest my case.
So it's like that's like, I mean, if that were to happen, I'm sure there'll be other forces that will, make sure that happens. That cannot happen.
Okay, we're going to go to our next question. We'll go to this question over here.
I'm Sabine Giraud. I'm a professor emeritus at Stanford University, and I'm very much enjoying this discussion because I think there's a lot of cross-fertilization. I want to pick up what you said, Dario, about scarcity and one source. What we just discussed, one source is available. And I would actually like to direct the question to Taiyin. And can you tell us a little bit about the international dependency of supply chains in the healthcare system? Because you showed this great slide of how over the last decades, our dependency on certain countries became really critical. And I think we see the same thing in the healthcare system, especially in the pharmaceutical system. You all know when we were in the pandemic, we couldn't get masks. Everybody knows that. But as a physician and surgeon, I know that we cannot get critical medication for our surgeries, for example, propofol. Yeah, this is manufactured in the United States. It's needed for anesthesia, so if any of you needs an operation, this is a critical problem. And I think this has something to do with quality control and also with the dependency on a global supply chain in healthcare. And can you tell us a little bit about the numbers, comparable to what we see in the CHIPS Act? And do we need a CHIPS Act for healthcare? Thank you.
Good question. Okay. So similar, I know Dario addressed, some of the global dependencies, but in the healthcare industry, do you want to tackle that, Taiyin?
Thanks for the question. It's more than 3 layers you have to look into because raw materials goes back deep. So there are 2 ways of thinking. One is the source of the real raw material and the processing forward to the next stage, right? And then you will find out, say, I do feel China, Russia, and Mongolia, there's the rare earth being the one of the resource that actually only come from 2 locations. So you do chemical catalysis, right? You do need to have certain oversight and that safety stock for these, right? So that's just the source of material, and then processing forward. Then it has to do with a lot of processing in the early stage of a raw material is hazardous, right? So that tend to happen in China. That there will be companies that specialize in doing that, and then the availability becomes very limited. And as far as in terms of quality in that, the quality is the burden of the user. So that is one thing that makes things in check, but doesn't necessarily ease the supply chains. You just have to have knowledge of the supply chain. The most important thing is know where things come from. Because you may be purchasing from a distributor, not the manufacturer, and therefore it is that's the alpha raw, we call it alpha raw materials. So you have to go that deep. Then talking about, say, guarding your knowledge. So it is important to have IP mined, right? Every company you interact with, as you advance to the actual intellectual properties, right? You need to have audits of their IP practices. So that's what, at least where I used to work, that we say this is something to protect your IP as well. So it's a factor, a multi-factor you have to protect from obtaining the knowledge. I can't stress enough knowing, right? If you don't know what you're losing, and you don't know what your risks are. So it does take I think the engineers, the chemists, the biologists, right? They're so good at knowing where the amino acids mostly come from China, right? Because that's a lot of isolation, and it's a low margin work and large volume work. So one has to know the reality. I mean, your cell culture media, right? It's a soup of all these amino acids. So you have to have good control and working with your media suppliers. And so you can never do your job within your own four walls, right? Just like discovery, right? Innovation doesn't come from the 3,000, the 12,000 people, or the 200 people. There could be 10 people somewhere, right? So nothing is about walling you up. Manufacturing capacity is also, the way I view it, the world is at your disposal. You have to reach out to understand and to manage them. So there's active management of the so-called contractors. I would call them partners, because you need them to do a good job more than they need to do a good job for themselves. So all that concept is to be built in your supply chain management. And that is not just as a logistics, it's treated as a science and business. I hope that answers a little bit.
I think so. I know we are getting close on time. I'm just going to do an honest check-in, Alan, how much we can push. Oh, is it noon? Oh, my goodness, I'm off a little bit. Sorry about that. A quarter of, okay. All right, great. Okay, we're going to go on to our next question over here.
My name is Surajit Chowdhury from Microsoft. So my question is not about the future, but about the present time. We're just coming out of the pandemic. What is the one most important change that you have implemented already in your supply chains? And my question is specifically directed in the health, so therefore Dr. Yang and Dr. Allgor on the retail.
All right, go ahead, Russ.
Okay. I think by and large with our supply chain, we've noticed one of the keys is just figuring out where and when to be ready for disruptions and be adaptable. So I think throughout the pandemic, we learned a lot about becoming adaptable. We changed most processes to keep people safe. And that was, doing that led, I think, people to redesign and think about how to use the capabilities and the technology we have to move forward. And so I think that was one thing. So it was like a crucible moment that helped the company to assess, how to use the resources we have in the most efficient way possible. So I think it really focused on what we already knew, which is, using resources efficiently is super important, but pushing when you know all the resources are going to be at capacity for a long period of time, how do you make sure that that's efficient?
So you talked about efficiency. If I may ask a question, are you taking into account essentially an unexpected event? The word is resilience here. It's not about making it super efficient. So sure, you need efficiency, but can you speak to the resiliency, what you have done to the supply chain?
I think most of the resiliency things that I've seen, and it's sort of the design, more or less, that's been sort of in, I think, the company's DNA for a long time, is not having single points of failure. And some of that not having single points of failure came from the design principles of a lot of the software engineering that started, which is distributed systems. So, Amazon on the software side, which is not my area of expertise, but went to service-oriented architectures a long time ago and pushed to try to make sure that things were distributed so that no single point of failure would break things. And that is also embedded in the operations. And so I think that's one of the keys, is no single point of failure is what's been done for resiliency more than anything else. If a node goes down for whatever reason, it doesn't bring down the ability to get products to customers. The products that are inside that node can't get out, but everything else still continues. So it's as much as possible in making sure the system in general can keep moving forward, even with disruptions. And those could be as small as a machine inside a facility goes down. There's these, most of the Amazon robotics fulfillment centers have pods of inventory. If something falls off and blocks a path, that doesn't block how the building functions. One, it can be removed efficiently or effectively, but everything gets rerouted immediately so that blockage doesn't resolve or result in an outcome that doesn't deliver at the end. So,
yeah,
that's the most important.
Go ahead, Steve.
I was just going to add one of the things. It wasn't related to COVID, but it's more related to Ukraine, another hotspot that popped up on everybody. We're trying to develop multiple places where we can manufacture. So we're working with our allies and partners, mainly in Europe, Germany and Poland, to actually build weapon systems there instead of just in the U.S., to have that multiple source of manufacturing in multiple locations, right? So that is a way we're fighting the anti-fragility of our DoD supply chain.
And speaking to the single points of failure, a lot of it involves investment, right? We learned earlier, that's why the CHIPS Act is so significant. And then not only CHIPS Act, but then also the private investment that's gone on top of that, right? Because it takes money to not be, just in time, I suppose.
Yeah.
All right, great. We have another question over here.
Thank you. My name is Janet Herring. I'm the Director Emerita of the Swiss Federal Institute of Aquatic Science and Technology, Professor Emerita at ETH Zurich and EPFL. I was really fascinated to get these insights into Amazon and how it functions and works, but I was sort of missing one element in that, and that's the human element. And I feel that a great deal of resilience, and to be honest, what I see in Switzerland, I'm not originally Swiss myself, is that the workforce is very well educated for the tasks that they're doing, and they take responsibility. There's a concept in Switzerland called subsidiarity, which is that there's responsibility at sort of the lowest level that's possible within an organization. And I really feel that Amazon especially could do a little bit better by its workforce, and I wonder, when is that thinking going to come in? And, for example, when might unions be better accommodated within Amazon? Thank you.
And I think we'll expand that question just about kind of the digital human side of things. We talked earlier about workforce development, needing more skilled labor, for a more resilient supply chain. So I know that was directed to Amazon, but I just want to open that up to our other speakers about, what in your respective sectors you're working on to develop workforce skills to complement this need for a more resilient supply chain. So does anyone want to tackle that first? I know you're getting a lot of questions, Russell.
Yeah.
Yeah, Dario, why don't you talk about workforce first?
Just on that framing specifically, look, I think it's come time also in our country. There was a very important piece of legislation on workforce, that is the NDEA, right? Like the National Defense Education Act that took place in 1958. As a consequence of what was perceived as a crisis at the time, right? The launch of Sputnik and the relative erosion of competitiveness that was perceived at the time in science and technology. And it was a very important piece of federal legislation to invest in science and technology education, also in foreign languages, interestingly, at the time, and broadly across the United States. And it had a profound impact on the number of engineers and scientists that were trained in the nation. And I think whether we're talking on supply chains or however you want to frame it, on supply chains, on leadership in technology, providing economic opportunity of people that want to participate in science and technology, it has really come time for an NDA 2.0, right, version of it. And I think we've all been part of endless and countless reports right, on the relative erosion that we've had on all through K through 12 and community colleges. Julia was bringing that up before, as well as in in higher education. So linked to this is has to be a commitment, which I'll take the spirit of that question, about investing in ourselves, right? Investing in our people. And we've talked about the supply chain element of physical infrastructure, of, a manufacturing facility, R&D facilities. But the companion of that story is to invest with, equal level of attention and vigor on the human capital piece of it. And that's through that entire supply chain of talent, so to speak, around that. So we're well past time to pay, that level of attention, what we'd have to do on the people side, right? And as I mentioned. And so I think that is the highest level of urgency that we can do. And if on these critical supply chain discussions, we can have this balance point of what do we have to do on infrastructure and R&D capacity and on the human dimension of it, I think we would build a much more resilient and robust system.
Go ahead, Russell.
I would just, to your point on the education and the training, as things get automated within facilities, we end up with opportunities for new jobs and things that get created. So robotic technicians and things like that. And the company supports that and trains people to do those new roles as they get created. So the nature of the work is changing through time.
As that work changes, the training is needed and education is needed through
happening,
the whole pipeline.
Yeah, and a lot of that.
Great. All right, next question over here.
I'm AJ Malshe. I'm from Purdue University and one of the co-organizers. So thank you for being here.
Hi, AJ.
I have a question. I study biological designs and models for resiliency. Because in the biological designs and system, you find a combination of resiliency, multifunctionality, and sustainability all in one platform. And that's what I study as a part of me. So coming back from that example, I'm starting to study because in some of my meetings, I hear about resiliency of in-space operations. So we are at a very earlier stage of building the supply chain between Earth and the Moon. So LEO, GEO, Lagrange points, and whatnot. But also in this dialogue, when I study even the consumer level problem. So typically last time when I heard the challenge or problem of resiliency was during the Second World War. So we are talking resiliency, and resiliency is a combination of efficiency and effectiveness. As engineers, we are really great trained to study efficiency, but effectiveness is something very qualitative. I've asked this question to a 3-star general and I say, in the war, do you want to be resilient? And if that is the case, do you want to be effective or efficient? And the answer was, I want to be effective. I don't care efficiency when I'm winning the war. So it appears, I don't want to sound alarmist, but we are in the already asynchronous Third World War scenario here, which is we have globalization, we have growing population, we have many hotspots, we have weakenings across the many parts of the supply chain. And if you consider the complexity of these problems, and we are just talking about efficiency, I think that is the least of my problem. My challenge is effectiveness. And
what's your question around effectiveness?
So my question, the effectiveness, how with CHIP Act or defense or bio or supply chains, the effectiveness can be measured or indexed or understood as the time passes. So as a nation, we can be effective addressing those challenges because you all connect with one word.
Great.
So thank you.
Great question. So as we build more resilient supply chains, our metrics change, and we're looking, at effectiveness, not just sort of bottom line, right? So Dario, I'm going to ask you, what are you seeing just in terms of sort of if you look at your looking glass into the future, what are some of those metrics to prove that we are building a more resilient supply chain, that we are effective in the goals that we've set out?
I'll go back to the chart I showed. Like if you look at semiconductors, right, you would say on both design, front end, and back end processing, including packaging, effectiveness in that context would be what is the percentage of capacity that you either have control over, right, or have a trusted assurance, right, if you're working with partners to meet the core obligations that you owe to your citizens, right? Or, and so on. And that includes, ensuring the security, health, right, and economic opportunity around that. So you don't need to reach 100% capacity on all of those metrics, right? Because, we don't have to do it all by ourselves. But certainly when you get to the point where you have zero capacity, for example, like we got below 10 nanometer production, that's a problem, right? So we need to debate what the right numbers are and what do we have to do, with allies, and I think that will ensure that effectiveness. But they're measurable, right? You can just see what percentage do we have, right, across all of those elements, and is that enough to be able to, in very adverse or complex situations, can we sort of like survive and allow us to fight for a better day, right, while the crisis is managed, if you maintain a certain threshold. And that's a quantitative number, and one can put a group of experts and leaders together to say how much capital is needed, how much time will be required, and what are the policies and investments that are required to deliver that outcome. But it can be measured.
Thank you. Thank you.
Great, thanks. Okay, we'll go over here for our next question.
I'm Bernd Giraud at Stanford University. I'm also the chair currently of Section 7, which includes electronics. So I'm going to ask you, Dario, first, and maybe then we can zoom out a little bit to the other industries and supply chains we've been talking about. But, we have a strategic oil reserve. The government keeps stockpiles of various vaccines, and Tamiflu was mentioned, and so are there opportunities in the semiconductor supply chain to become less brittle in case of geopolitical crisis by the government stepping in and having certain strategic reserves?
Definitely. So look, I'll connect it to an idea and a project that I was connected, and then I'll address that specifically. During the pandemic, I led an effort in collaboration with national laboratories and others on creating what was at the time called the COVID-19 High Performance Computing Consortia. And that was the idea, is to aggregate supercomputing capacity and make it available to scientists that were working dealing with with COVID-19. And that led to an idea, borrowing the term, of creating a national strategic computing reserve. And sort of with similar parallels, where you could sort of aggregate capacity, right, that is existing, as well as data sets and and talent, that in the case of a crisis, one could mobilize to deal with that in computing. Part of that idea can be extended to the components themselves. So you could imagine stockpiling, within reason, certain amount of components that are dependency. By the way, this happens also, we do that as part of the tool of managing crisis in the private sector with buy-aheads, right? So you buy, a certain amount of production that you're going to do. It's a trade-off between inventory, right, and efficiency. But certainly now in the world of semiconductors, using that knob at the level of an institution, at the level of a nation, is an appropriate knob to use. And I think parallels like oil and other things, airlift capacity is also reserved. There's lots of things that are that, and I think for the world of electronics is an appropriate lever to use as well.
I'll just add, along the lines of your question, one of the things Lockheed's leading in defense, one of the issues with defense, one of our challenges is we have low volume production, right? And so I think we buy less than 2% of the microelectronics in the country. But one of the things we're trying to do is increase our volume by focusing on this idea of chiplets, which you're probably familiar with. DARPA did a study back in 2016 that showed, 90% of DoD microelectronics requirements could be done with 17 different chiplets put together in different ways. And so we're focused on that as a strategy as we move forward to be able to design these various chiplet packages. There's technologies associated with that, interposer, how you integrate it all. But if we can make that a reality, I think we can increase our volume that DoD is focused on. It's good for the CHIPS Act. It's good for the U.S. now that we have the CHIPS Act supporting these various facilities in the United States. It's going to be good for defense because, we need a trusted supply chain when it comes to microelectronics. So there are things we can do to increase volume, increase our capacity to buy, and we're focused on that.
Out of curiosity, does the government actually have a stockpile of rare earth?
Good question. I think it was much like, my understanding of it is it was much like microelectronics years ago. If they needed it, they would just buy it from China and Russia and others. And we've seen that's not a great way to go, right? Because, yeah, okay. Yeah. Okay. So that's another area we got to look at for sure as a nation, and focus on how we do that. It's not just rare earths, by the way. It's the whole Ukraine thing closed down the Russian titanium production to the U.S. And so what we've seen on the defense side is U.S. commercial companies that use titanium are focused on the U.S. Titanium industry, and we're having a hard time buying titanium in defense. So there's all these pressures in supply that it's rare earths, but it's also just normal materials.
Okay, our last question is over here.
Hi, Duraj Jagannath from University of Texas at Arlington. So this is addressed to Dario. So as the need for monolithic SoCs is reduced and we're looking at advanced packaging and chiplets, how do fabless chip makers expand business models to accommodate advanced packaging? And what are the supply chain challenges there? And can you also talk about the impact on fab a little bit? And what about workforce development and resiliency, both the silicon, but primarily advanced packaging as well? Sorry, a bunch of stuff.
There was a lot in there.
Yeah.
Which one would you like to take?
So look, I'll just briefly
ex-IBMer, by the way.
I'll briefly touch on two things because it came out during the morning's discussions. It goes back to your business model question around that. Part of the reason why we ended up with also such a high concentration, right, of manufacturing in Taiwan, and including in packaging and so on, had to do with business model innovation too. Right? I mean, the innovation of TSMC there, right, as pioneering a fabless, enabling a foundry business and not have an integrated device manufacturing approach, turned out to enable economies of scale and productivity levels that others found hard to match to, right? And led, as a consequence of a business model innovation, to higher concentration of manufacturing around that. So part of what we have to innovate is not only on the R&D side of the house, as important as it, but on the business model around that. And I'll just touch on what Steve mentioned on chiplets. Creating an ecosystem of chiplets such that there's both the vibrancy of the design associated with those chiplets, but also with higher volumes, as Steve correctly pointed out, that would enable economies of scale. And then the integration of those chiplets, with the right packaging technology that we can use it, in a wide variety of sectors, is an example at the intersection of R&D and business model innovation and an ecosystem that would make it sustainable. So we have to unleash that element as well. And that's incredibly important because one of the traps very often we can fall when we design these kinds of policies is to not accommodate for the scale that is required to be successful. And, and I was a big champion of the CHIPS Act, and I really believe in that and why it is important. But let's just put it in context. $53 billion, right? The semiconductor industry, it's a $600 billion a year annual industry. Typical, like if you look at a company like TSMC, an annual capital plan of TSMC is in excess of $30 billion a year, to give you a sense. So unless we're able to mobilize sort of the business and economic forces on these science and technology priorities, it's very hard to reverse sort of like those vectors. And so we are going to need to be ambidextrous on both elements of it, right? What is the R&D element and the policy element, but also what is the business model and economic incentive model to make this sustainable as well. So I'll give one last observation around that, for example, look at it in the government perspective. Okay, so we have this appetite towards promoting certain investments, but on the procurement side of the government, there are requirements of procuring from the lowest cost provider. So that creates a tension, because if manufacturing some of these elements and parts is more expensive in the United States than elsewhere, which it is a fact, right? Then at the level of procurement, what are we incentivizing? Producing the part here or elsewhere? So all of this is intertwined, and it's just an appeal to sort of also direct the economic forces that make things scalable and sustainable.
Thank you.
Great, thank you. Jean Tom from Section 3. This question is a follow-up of a question to Dr. Taiyin Yang earlier. So the movement of manufacturing for components for pharmaceutical drug products to China and India is a relatively recent phenomenon in the last 25 years. What role do you see in terms of the federal government, whether it's the regulatory agencies or other parts that would enable pharma companies to bring back that manufacturing which was occurring some 30 years ago here?
I think to bring back really is about the presence of the industry working at entire supply chain components. So I think that is still not quite the case in the US. So you can look at the final few steps, but to really make a difference, the early steps are actually sometimes have higher value. So I do see is to create some incentive to have companies that can take on the end-to-end. I think at least one doesn't have to think about having the entire world supply made onshore, because pharmaceutical industry struck innovation should be available to patient in need where they need it, right? So so the pharma can still leverage a broader supply chain and broader manufacturing sites. But for the U.S., still just there isn't a lot of the end-to-end availability. At least this is when I was looking for, right, 2 years ago. But I think the change hasn't really happened. But there's a lot of conversation around Biosecure Act, these biotech companies of concern, but they're really not impacting the supply chain. So a different set of incentive and real actions and investment, not just on the high end of making the injection pen, right, for weight loss. It's about making the peptides. Right? The peptides, it will be a lot more involved in a lot of raw materials actually just not available here. So I do think it will take time. The supply chain takes easily 5 years to transform. So just in case, it's stemming from that. So in the meantime, the availability is lacking, and I wouldn't want to do a lot of quality oversight, right? Because there are also places you have to handpick to know where you can really establish that trust that they can deliver quality work day in, day out without the client looking over constantly, right? So there have been several that is at that stage. Even that is being under threatened, right? So my thought is pharma should bring a good amount within onshoring, but there has to be availability. I do think cost efficiency is not a crime. It's a way of doing business. But the lowest bid never works. So never go for the lowest bid.
Yes.
Good way to end supply chain.
That's a good way to end the whole thing. Never go for the lowest bid.
On that note.
Just want to say thank you to Dario, Steve, Taiyin, and Russell, for sharing all of your insight here today. Thank you to everyone who asked so many wonderful questions. And I just want to remind everyone that, the point of these forums is really just to spark a dialogue. So, we got a glimpse today of this conversation related to computing and electronics, defense and aerospace, healthcare, and transportation and logistics. But we really encourage you to take this conversation, continue with it. I mean, you're the leaders of our nation in engineering, and think about how to develop more resilient supply chains in each of your sectors as well. So thank you so much for all of your questions. Thank you so much for being phenomenal panelists, and I will pass it over to Al.
And thank you all again, and I will note, what a way to celebrate our 60th anniversary. This is the 10th one of these that I've worked on organizing, and this is the first time that the plenary speaker, Lori, and all 4 of the panelists are members of NAE. So there you go.